Good morning, one and all present here. This is Padmavati. I'm working in Department of Computer Science and Engineering in Sri Venkateshwara College of Engineering. And today we are going to discuss a topic on spatial filtering and what are the types of facial filters. First, we need to understand what is spatial filters. Here, if you have an image, then you need to take a sub-image. Those sub-images are called as filter, mask, kernel, template, or window. And here the linear filters which you can take, that means if I'm going to take, if suppose I'm going to take a linear that means a linear window, so that window can be placed upon the mask, and this process is basically used for filtering concepts. That means the concept of filtering has its roots in the use of Fourier transform for signal processing, which is called as the frequency domain. And here the spatial filtering, it is to differentiate the type of process from the moderate traditional frequency domain filtering. Usually we are doing frequency domain filtering, and from frequency domain filtering we are going to segregate or separate the spatial filtering. See, in this image we can clearly see the process consisting of moving the filtering mask from point to point. This is a mask, and we are going to keep a mask on the image. F represents the image and W represents the mask, and we are going to keep the mask on an image from the center point 0 comma 0, and the process simply moving the filter mask from point to point in an image. At each point x comma y, the response of the filter at that point is calculated using the predefined relationships. And here, for linear spatial filtering, the response will be nothing but sum of the product of filter coefficient and the mask. For example, if I am going to keep a mask over my image, I need to calculate the response. Then I need to move the mask to the next point. Again, I need to calculate the response. Again, I need to move to the next point. Again, I need to calculate the response. So this is nothing but the calculation. For example, if I have a mask over here, a point. So at each and every point that is in the center, I need to get. For example, here I have mentioned the neighborhood of a point x comma y can be defined by using a square or rectangular or circular subimage area centered at x comma y. The center of the subimage is moved from pixel to pixel starting at the top of the corner. See, top of the corner means it is 0 comma 0. From 0 comma 0, I'm going to calculate. And here we can get the response. G of x comma y is nothing but the final image. G of x comma y is nothing but the final image. See, this is my original image. I'm going to applying a filter, and then I'm going to get my image. See, sometimes G of x comma y is called as degraded image, and sometimes is called as output image. And suppose if I'm using some filter, then I'm getting this output, then it is called as filtered image. So in spatial filtering process, the main thing what we are going to do, first we need to select a small rectangle. Either your mask will be 3 cross 3, 5 cross 5, or 7 cross 7, depends upon your value. And here we need to define the predefined operation on an input image, and the window center moves from the first 0 comma 0 pixel and moves till the end of the first row, and then to the second row, and then to the third row till your m minus 1 to n minus 1 of your input image. After that, we need to calculate the complete values. That means the filtering process can be created, and then the new pixel in the image at the window neighborhood center as it moves, and then you are getting the filtered image, and this will be the response. That means where I am going to keep my window. For example, if I am going to take my mask as above this image, this is nothing but the masked image. So I'm going to keep this mask on a larger image, which is not 3 cross 3, which may be 7 cross 7 or 9 cross 9, like that. First, I need to calculate the value. For example, as it was here, need to move on to the first row. Then again I need to shift 1 point down and I have to move on to the second row completely till the end. Then I have to move on to the third row and then I need to calculate it completely towards the last point till m minus 1 to n minus 1, where m minus 1 represents the last row and n minus 1 represents the last column. So this process can be done for filtering of your image. And whenever you are getting the output of the image g of x comma y, which is called as a filtering of image, that is called as filtered image. And here I have given the difference between the smoothing operation, what are the types of filters you can use and what are the things you can get, I have given. And here there are various types of, see, one more concept I forgot to tell here. There are various types of noise is available: salt and pepper noise, impulse noise, and maximum noise, minimum noise. Everything will be present over your image. So those things can be cleared off using this filtering operation. So here, and this is nothing but the transfer function. This is the normal thing, g of x comma y, where you are using the transfer function of f of x comma y, where this t is nothing but whatever the filter or whatever the operations which you are applying over your input image. F of x comma y is my input image and g of x comma y is the filtered image. So here we can understand about the basics of filtering process. And in basics of filtering process, the main thing is we are going to keep a mask over our uh, we are going to keep a mask over our input image, and we are going to calculate the response r. Response r in the sense we need to calculate for each and every point, we need to calculate the response for m cross n image at the point x and y. So this is about the response calculation by using spatial filtering technique using masks. Thank you.